All right, hello everyone. Welcome to Handmade Hero, the show where we code a complete game live on Twitch from scratch, no libraries, no engine. And today is kind of a good day, I think. We'll have to see how it goes. You know, you never can count your chickens before they hatch. Sometimes they hatch into little stillborn chicken fetuses, and that's no good for anybody. But what I will say is, you know, like I said when we started this, I was like, one of the big things that we're doing here is we're trying to put enough code down in sort of like a primitive form that we can tell how everything should be structured. So that when we go and we start writing individual pieces that are meant to be shippable quality, we don't fall into the standard trap of over-designing, under-designing, designing the wrong thing, doing all the sorts of things that happen when you don't write the usage code first, right? I've said that many times, always write the usage code first, and it's very important. So that's what we've been doing, and the entire time that we've been doing it, I've been looking at some more advanced features in the entity stuff, the low and high frequency set thing, and being able to scale to large numbers of entities and that sort of stuff. And so that's something that we wanted to do, but it was never quite clear exactly how we could architect the code to make that work nice and cleanly. But that was okay for me because, like I said, the important thing is to get enough code down so that you can see, and slowly over time, good solutions to how you want to do things architecturally kind of work their way up from the code that you have down there. And so it's really just a matter of sticking it through and doing enough sort of trying of things that you want to accomplish to get to the point where you can actually do it. And so after the stream last night, I was lying in bed, and normally I'm not super good at falling asleep. So typically what happens is I'll like go to bed and then I'll just get up like 30 minutes later because it's pretty clear that I'm not going to fall asleep, and then I'll do some stuff for a while, and then I'll go back and try to fall asleep again later. So I was lying in bed, and what I realized is I finally realized, I think, the crucial thing that with the high and low frequency stuff that can make it into a nice clean architecture. And so I want to talk a little bit about that, because I was pretty psyched. I was like, yes, this is the thing that I've been waiting to sort of see click in a good way. So what I realized is, and what day are we here on Handmade Hero? We're day 63. So what I realized here on day 63, right? Or I guess this was day 62 when I realized it. But I realized we have two constraints that are coming together, right? We have two constraints. The constraints are, number one, we want a extremely large world, right? So we want to be able to handle worlds that are so large that floating point accuracy would immediately degrade if you were to try to store them all as single floats, right? So we wanted to say that our engine could support that. Again, not because any particular engine has to support that, but rather because we want to show how you handle it in code, because it is something that does come up if you want to do large worlds and you want to do them right. So I wanted to put that in there. We had another thing, which is extremely large entity counts, right? So we basically have two scalability things that we wanted to talk about. One is about float precision, right? And one is about basically about processing power, if you will, right? This is about processing power. The problem with extremely large worlds is that we will run out of precision in a 32-bit float to deal with them if we just did everything in float and said, hey, whatever, anything goes. The problem with extremely large entity counts is that we don't have enough processing power to basically to just write code where we write the code for every entity and then just run all the entities in the world all the time. That will never scale to very large entity counts. So we have two competing concerns here. And what I realized is I was not thinking about them together. I was not thinking about how they related to each other. I was implicitly dealing with their intersection, but I wasn't thinking about it overtly. And so what I realized is that if you think about it overtly, I think that shows the way to doing the good architecture that handles both of these things, which is our goal in this design process, right? So let's talk about that. What does this float precision thing make us do? If we don't want to just use doubles, if we don't want to just go to 64-bit floating point, which there's a number of reasons we don't want to do. A, they're half as fast. B, there's platforms that don't support them at all natively. C, we don't actually necessarily even need that much precision, blah, 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 blah. There's all sorts of reasons why it might not be a good idea to strictly go to doubles, right? But the real big one is just the performance, right? We know that we're going to be half as fast if we did that. So we'd like to make sure that most of all of our stuff that's happening all of the computations that we do for everything, we'd like to be able to do those at full speed. We'd like to be able to do them in float so that we can be fully 4 wide on 8 wide or 16 wide on SIMD instead of 2 wide, 4 wide, or 8 wide on SIMD, right? So we get basically twice the performance if we're in float. So what we want to do is we want to be able to live in that world, right? We want to be able to live in that world. But what that means is that whenever we do our calculations, if we're doing everything in float, we have to be doing it around some origin point that's local, right? So what that means is if we have people everywhere in the world, right? And this is the giant world, let's say, right? This is the giant world. If we're looking at the giant world and we say that we have all these entities that are like over here, right? And we want to talk about how they work. In order to process them all, what we do is we first pick a local origin. And what we were using was the camera for this in our current code, right? We would take the camera and we would just figure out where everyone was relative to the camera, right? So if you imagine what happens, we're taking a little slice of the world, right? And we're saying wherever the camera is, we just say where the entities are relative to that camera. And then because we know that's a very small neighborhood, right? That's only, a few meters across. We're talking about like a 50 meter by 50 meter square, right? Whereas this might be like hundreds of kilometers or something. Who knows? I don't remember what we calculated it, but this is huge and this is tiny. This is not a problem for float precision. We have plenty of precision here and we could do all our calculations in float no problem, right? So what this implies is that we're always doing these calculations, right, in a local neighborhood, okay? And so that's what led us to the whole, we had low frequency and we had high frequency entities, right? And what we were doing there is we were saying we were storing basically like an extended detail version of where the entity was that involved tile positions, right? Like a tile chunk position and an offset, right? So we were basically storing, and alternatively, like again, if we were on machines that support doubles, we could store doubles here. But basically we had like the slow version of where people were in this low entity, right? But the high version of where they were was just in a vector 2, right? It was a vector 2 float. So basically this gets translated to this and we would do our calculations here. But then we kept having, I don't even want to say problems necessarily, but you could tell even just from an early standpoint that there was just a lot of fussing involved in us having to think about which state we were talking about, whether it was this position or that position, and keeping these two things in sync and all this other nonsense. And it was really just a drag on the coding, right? So there's that. But there's another problem, and there's a problem that we hadn't actually gotten to yet, but that we sort of were setting up to deal with, which is the scaling to extremely large entity counts. And basically what that was saying, okay, so there's low frequency entities and high frequency entities, right? All of the entities always exist in the low frequency set, essentially. They're the data that actually describes the entity. And then there's this high frequency version of the entity that we actually use for processing that has some additional stuff in it, right? And that's how we were handling this. And what I said was, well, we're going to want to be able to do processing on these low entities because we want things in the world to keep happening even when you're not around it. So we want to be able to sort of have people who are maybe, like the example I gave was, let's say there's like a creature or a guy who's like going to go somewhere, take something from a location and bring it back, I don't know, to his lair or something. Who knows? There's something going on out here. And we want that to kind of keep going on because it might be nice, give the world a nice emergent feel when the player comes upon this and sees that like all of the apples are missing from here and they go to this little apple thief and he's got all these apples in his back room, or I don't know, picking stupid things, but you know what I mean. You want to be able to see that sort of thing happen. And furthermore, if you came right here and watched, you would see this guy come back carrying an apple and all that sort of stuff, right? We want to support those kinds of things because, again, hard to program, ergo, we want to show it on the stream because the whole point here is to learn how to do advanced programming techniques. So what I said was, well, we'll have the low frequency set, and then what we'll do is we'll just operate on this low frequency set at a lower rate, and then the high frequency set will be where all the magic happens, so things that are close that are in the camera view get the high frequency detail, and so on and so forth, right? But in the back of my head, I was really worried about this because I'm like, well, now we have to write every entity's code twice, right? We have to write like code that works for when they're high frequency entities and code that works for their low frequency. Like, that doesn't sound very good. I don't really know what to do about that. You know, it seems like there's going to be a lot of work there, and it just sounded bad, right? So that was worrying me as well. So all of this stuff was kind of built up. So what I realized when I started was sort of not even really thinking about it. It just kind of like must have been a background process in the brain. Was I realized that that was exactly the wrong way to think about the low frequency entities, right? Thinking of range-based processing of them was just plain dumb. That was dumb. There was really no reason to think about them in terms of index ranges, right? You remember I even said it on the stream. I was like, let's go ahead and we'll just process like 1,000 of them at a time or something, right? That doesn't make any sense. Why would you do that? That is what would cause you to have to write things that operate directly on the low entities. Instead of doing that, why not just basically have a second camera, right? Have a second camera that just moves around the world, simulating the pieces of the world in chunks, right? So that every frame you do 2 camera things, basically, right? You do the ones for where you can see, which should always be simulated, and then periodically at a lower frequency, you know, you will basically sweep through all the other parts of the world, focusing the camera on them, the virtual camera in this case, map all the things into the high entity space, do the processing, map them back to low, right? So basically, what that means is now we can get rid of the concept of ever operating on a low entity at all, right? You will never touch a low entity. There's never any reason to, right? It's strictly a storage format, which is what I kind of wanted when I started, but I just couldn't figure out how to do because of this dumb thing, right? It's like I would have rather had it so that, you know, I would rather have always thought of low entities as just like a compressed or like an archival format, right? For my high ones, they map into here and they sleep in this state, right? And then they map back. That's how we would do it in a normal game that wasn't trying to simulate things anywhere, right? That was doing something simpler than what we're trying to do here. We just compress the high entities or map the high entities back into here, you know, and some of it's not compression, some of it's actually expansion, like it's storing it in this more detailed format for the position, for example, right? But in general, you know what I'm saying? We archive them to low, and then we bring them back from low into high when they come back on the screen. That's what we would normally do. And so the thing that was causing me all the problems, though, was I was like, we can't really do that because we want them to still be live. Well, we can. All we have to do is just always use regional processing. I don't know why I didn't think of it before, but that's just the way programming works. And it's the reason that I say to always do things by writing the code first, is because you need to give yourself the time to realize things. They're always going to be obvious in hindsight, but if you don't get the stuff out on the page, right, or in the editor, I should say, and you don't have some time to look at how it's actually working in reality, you're never going to be able to have those insights because you just don't have the information you need. And so this leads us to what I think is a very good way of structuring this, and we're going to start on it today. I don't think we'll finish because we have some restructuring to do. But basically what it's going to be is you never touch low entities. So low entities are never stored. They're a storage format only, right? So what happens is we have a new concept, basically. I don't know exactly what we'll call this, right? But we'll basically say there's a simulation region. Okay. And again, this is exactly what I was talking about when I say engine architecture. You do it by seeing how things go, and then you pull up from there. And that's exactly what we're doing. We're looking at what happened, and we're going, now I can finally see how things are supposed to work. Now I can really see a very important piece of my architecture come to fruition. So what we'll do is we'll have this thing called a simulation region. A simulation region is a rectangle in space, just like we sort of had already with the camera, right? But it's completely self-contained in the code. So it stores a high entity list for itself, right? It stores its bounds, and it's got a very well-defined beginning and ending, right? In time, in the code. So we start it, we map all of the entities into high for that, we run the processing, and then we map them all back to low, right? So basically this is an entirely self-contained thing in the code, a simulation region. You can do them anywhere you want, and you can do as many of them as you want. And they come and they go, right? They never persist across a frame boundary ever, right? And if we ever wanted them to persist across the frame boundary, that would be an optimization. So basically, that would be something we'd add after the fact. So that means now we don't have to write two pieces of code. All the pieces of code for simulation always happen exactly the same way, right? Always exactly the same. So that totally simplifies our life quite a bit and gives us one of our key architecture components, assuming, again, that it works out when we go try it. And so this is basically like, this is a key component right here. That all makes sense? Hopefully. So again, not terribly different from what we've been doing. It's very similar, but it organizes all of the pieces properly so that the problems that we were having with our current system don't happen anymore, right? And basically, no one ever looks like we had these problems with moving entities, writing back to the low, and all this other stuff. All of that is now totally gone because everything only happens on high detail entities, and only at the very end are things all written back to low as a storage format only. And I really like that because that to me seems really, really pretty darn good. Okay. Now there's one thing I want to mention, which is like sort of the slight wrinkle, which has nothing to do with this exactly. We would have had it in the other system as well, but something I just want to kind of point out because I think we gotta design in some, what's the word for it? Affordances for it. One thing that we never actually dealt with, and I think we can deal with it pretty easily now, is that in the past, when we map things into our active region, let's say this is the active region here, this dotted line, then we have entities, right, in the world. Here's some entities in the world, and here are some more entities in the world. If we simulate all of the entities in this region, we have a problem, and that is that entities near the boundary may be allowed to move outside of the boundary, because on their time step, they'd be able to move across that boundary, and in crossing that boundary, right, they will not collision detect with any things that were outside of the boundary. An entity that was right here, or right here, would never have been brought into the high frequency set because it's outside of that boundary. So what we need to be able to do is we need to be able to say, okay, simulation actually happens inside a conservative boundary that is less than the one frame movement distance away, is more than the one frame distance movement away from a secondary boundary, which is where everything gets pulled in. So this outer boundary is basically the high boundary, and this is like the sim boundary. So things in here get simmed, things in here get pulled in but not simmed. So they're just standing there as colliders in case something tries to go out there and hit one of them, right? But they themselves are not allowed to move, right? At least not in this simulation pass. Does that make sense? They could still be active entities, and they still could be simulated by something that went and did another simulation region that was right here or something like this, right? But what we want to do is make sure that we essentially don't ever have that case where something could go outside of where it needs to go, right? Where it's allowed to go. So there's another thing to think about. All right, so I hope that all makes sense. I'm going to go ahead and start the process of making that happen. Like I said, that's going to take a little bit of reorganization, which tends to be a little slow when we do it on the stream because as I explain things, right, there's a lot of text moving around and doing stuff that maybe makes things a little slower than it would be if we were just going to reorganize it flat out. But even so, I mean, even when you're just programming not on a stream, it does take a while to do all the text shuffling and stuff that's necessary inside a reorganization, right? So that's worth noting. It's never really that fast to do. So it's going to take a little bit of time, but I think it's definitely the right thing to do. So I'm going to go ahead and just flat out start that process, get us into a position that does exactly what I just said, because we already have all the usage code written, essentially, that should guide us and allow us to know that we have all the stuff that we need to support it. So, first things first. Let's go ahead and say that we have a handmade simulation region. I liked that name. It seemed good enough to me. And so we have a handmade simulation region. Well, I don't actually need to call it handmade simulation region. Just simulation region will be fine. I guess I could call it sim region, but I don't know. Yeah, it's okay. All right. We'll call it sim. We'll call it sim region. No need to introduce extra characters for no real reason. So let's call it handmade sim region. That's good enough. All right, struct sim region. And a sim region is gonna, what I'm gonna do basically is I'm gonna move the stuff that used to be fast and loose and kind of always existing in two places. I'm gonna move that over to the simulation region. So basically this over here is gonna look like that, right? And I'm gonna call these just flat out entities because everything's gonna work on these entities primarily, right? So we're gonna have an entity count and then we're gonna have an entity array, right? And that's gonna look like this. Now I'm going to get rid of this cap here, this entity cap. I'm going to say that we just have a pointer, and the pointer points to however many is in this entity count structure, right? I might say that we also have a max entity count that can exist here. So maybe there's some headroom on this when we actually make it. I'm not sure that we even need that, but we'll just leave that there for now. Okay. So that's our sim region. None of these other things are particularly relevant to the sim region. But now what we know is we kind of have this, we've got this sort of set camera call. And what I'm going to do is I'm going to say that this is going to get broken up now, right? So instead of a thing that goes through and looks whether things need to get mapped out of the high frequency space into the low frequency space, this offset and check frequency by area thing, that's now no longer on the table, right? Everyone gets mapped in and out of the high frequency space every frame. That's just how we're going to do it. And like I said, if it turns out that that's too slow, then what we'll do is we'll go ahead and we'll optimize it later as a separate thing that we do. But there's no sense in basically premature optimizing that at this point. So in our sim region, what I want to do is take that offset and check frequency by area call, right? Offset and check frequency by area call, and take a look at that. And you can see that basically all that does was it was moving things, packing things into low entities as they went. But that's really, you know, it's really pretty basic. So really all we have to do is just make, I don't even really need to cut and paste that, right? It's super, super simple. There's really nothing to it. All we're doing here is saying like end simulation region or something, right? End sim region. Or I guess we could just call it end sim, right? And that takes the sim region. Okay. And then when I do that end sim, I'm going to loop through all the entity count. You know, I'm going to take this. I'm going to say for each entity, right? So I've got an entity index here. For each entity that's in the region, I want to map that entity out and into the low space, right? So right here, again, we'd have that high entity, right? And I guess we don't call them high entities anymore. They're just going to be entities. So then we have an entity, right, like so. That's going to point to this guy. It's going to point to the entities that are in the region. And each time through, I'm going to advance that pointer, right? And so what we do each time through here is we just map the entity into the low space, right? So basically what we're going to do here is, I don't know what we'll call this exactly, but I guess we'll say store entity, right? Or something like that. So we'll have load entity and store entity, I guess is what we'll call them. We'll load them out of the sort of that backend store, and then we'll store them back to it. So we're going to store this entity out. And so what we would need to know there is where we're storing the entity to. We'll assume right now that that's stored in the entity structure itself, because that seems logical, right? So we'll just do a store entity. We'll write that in a second. That may be something that we actually write here. In fact, we could just say store entity. And the reason that we don't really need a function for it is because I'm thinking that, like I said, we will probably want to do it so that you literally never, ever, ever translate between high, low frequencies, any of that stuff manually ever. There's just a controlled load and store. It can only happen in one place, and it happens exactly the same way every time. So it might just happen right on in here, right? So whatever we're going to call that in a second. So then we also have the same thing here, right? Which is begin sim. And that, again, is going to take a sim region. Or I guess rather what it probably would do is return a sim region. So you'll do a begin sim, you get a sim region back. Then you can do your sim on that sim region. When you're done, you end. Right? Makes sense? Makes sense. So inside begin sim, what we would be doing here is we would be doing the stuff that was happening in this call right here. I like how we said do this in terms of tile chunks for it to do, which is exactly what we did. So what we want to do here again, is take this code that we already wrote that just looks at sort of that region in our spatial partition. It says what are all the entities in it, and any of those entities that basically fall within the camera bounds are going to, we're going to find them, right? We're going to pull them out. And so what we can do here is say that when you do your begin sim, you just pass in that rectangle, whatever the rectangle is you're trying to sim, right? So this is the bounds of the region. You pass that to begin sim, and then that's what we use for everything, right? So camera bounds is now just region bounds, right? Region bounds, like so. And the region bounds, I guess we need to also give you what it's centered around, because that needs to be one of those higher frequency positions, right? That needs to be one of the more specific things, right? So this is the region center, and that's the region bounds, like so. And so new camera P is just region center, right? So there we go. So we go ahead and we loop through all of these things. We find all of the entities that are relevant to us, and then we're going to go ahead and map them out. This also means that now the low entities, right, we no longer have the double pointer situation, which is really good. We no longer have low entities pointing to highs and highs back to lows. We only have entities that point back to their storage location, right? Because that's something that we presumably always want to be able to do correctly, right? Furthermore, things are going to get even better, people. They're going to get even better, just you wait. I can see it coming down the pipe. I can see it. Can you see it? Yeah, maybe you can't see it. Doesn't matter. It's there. All right, anyway. So if we go ahead through here and we say, all right, we've got our low entity. It no longer has to point to the high entity because that's not relevant anymore, right? And then we no longer need this entity structure because you're only ever going to be dealing with one or the other kind of entity, I believe. I think we're going to want to do that so that everything kind of gets moved up into the high entity. I'm not sure exactly how we'll handle that for now. We're going to have to think about that a little bit more. So this will go away eventually, but I think I'm going to leave it just for a little bit because as we sort of port the code over, I don't want to go too far too fast. All right, so basically the low entity indexes, we now no longer have to check to see or anything whether they need to be moved in because everyone needs to get moved in because no one's in the state yet, right? So what we need to do is we need to be able to sort of pull those guys in. And so what we're going to do here, I don't know exactly, one of the things is when we do this begin sim, it's a little unclear how we exactly want to divide up the memory that we're using because I don't know how much we care about whether the entity array is contiguous or not. It's something that, and we don't know exactly how we're going to process these. So I'm not going to think too hard about that yet, but later on, because we want this to be relatively, we want this code to be relatively fast because once you build one of these begin sims, we want all the code that happens inside it to be fast. We may have to think about how we're going to actually place these things in memory. But for right now, I'm not going to think about that too much. All right, so we go through the entity indexes. We grab out where they are. We then have a pointer to the low. And so then right here, what we need to do is we need to add an entity to the sim region, right? So this would basically add a low entity to the sim region. And we'll call that, I guess I'll just call that sim for now. I'll call it sim region. Call it sim region. And that, I guess we need to do the check of the camera space P as well. So this actually doesn't need to happen, but this does because we don't want to move it into anything that's not really in the camera region. So we'll do that. And so there we go. So that's the check right there. If it's in the rectangle, we'll add it in. And we already know where the camera space P is. So I feel like that should happen here as well, right? So that's where that is in camera space. So that looks good. So that allows us to add an entity to it. So here we'll go, add entity, like so. And I think that's about it for that function for now. All right. So add entity is going to take a sim region. And it's going to add a new entity to the end here, right? So for now, we're going to do an assertion on this, or I guess we'll do an if statement, like so. We'll do an if to verify that we have enough room. So we want to make sure that the entity count is less than how many we were allowed to store. And like I said, later we might allow this to be more flexible. We'll see how I feel about it later on. But assuming we're good to go there, I'm going to do an invalid code path here as well, just so we know that it'll assert when that hits so we can see whether we're overflowing our cap. So we'll go ahead and do the fact that the entities, sim region entities, like so. So basically all we're going to do is we're going to use a new entity from that entity list after making sure that we've got enough, entity array. And then that will go ahead and add the entity. Now we've got the low entity, the low compressed version of him here. I guess what I probably should do too is this should be a fairly simplistic, relatively straightforward entity. I don't know, we could call this a sim entity as well. Maybe I should, just to differentiate it. I like that. I like that a lot. So I think maybe we'll call that a sim entity. Yeah, okay, that's good. So let's call that a sim entity, and we'll return that from here as well. All right, sim entity. And we will grab it like that. So that will add an entity, but it won't do anything particular to it. I'm going to clear it for now. Like I said, I'm not sure whether we actually care about that too much. To do Casey, see what we want to do about clearing policy when the entity system is more fleshed out. But for now, I'd like to clear to 0 just to avoid bugs of that nature, because that way we know everything is always, every time you make an entity, is always cleared to a good initial state. What I also could do is just clear out the whole array at startup. I don't know, we'll think about that. But anyway, so when we get new entities, this will basically give them back to us, and that's fine. So the entities get added in there. And I think that's really all we need to do for that for now. And then in the case where you've got an entity, that just gives you a new entity. In the case where you're trying to add an entity in a slightly more verbose fashion, where you've got both the low entity version, right? And so I guess, I don't know what we're going to call this. I think we're going to call this a storage entity probably, right? I know we could call it a world entity. We could have sim entities and world entities. So world entities are ones that are stored out in the world thing. I'm not sure exactly what they should be called. Sim entity sounds good to me because the entity that's involved in a simulation region. That makes sense. World entity maybe is the right thing because that's what it is. We have the world storage. We could change the name of that. Instead of making it a world, we could call that like spatial part. I don't know. We're going to call it world entity for now. So we'll basically say this is the source entity, and this is going to be the dest entity. So basically we have a dest entity that's going to get received from here. And assuming that we get one, we're going to say, okay, map or like convert the stored entity to a simulation entity, right? So I don't know. Yeah, I think stored is the right thing because that's what I used here when I was talking about it. So I think we're going to call it a stored entity. I like that. And then I could call that stored as well, maybe. Yeah, source is good. All right, so let's do it like that. And then we also know here that our, oops, that's a typo. We also know here that our entity is potentially going to have a position passed to it, right? Like we did here when you're creating one out of, out of whole cloth like that. We know that you're going to have a world position for them as well, right? And so that's going to be, oh, sorry, I shouldn't say world position, a simulation position, because you've already done the check to see whether you should move in, so you've already got that, right? And so basically his simulation position is just going to get set directly and doesn't have to be computed, right? So that seems like a good idea. What I could do is make this an address, do something like that, and then make this a pointer like so. And then I could say, if we know what it is, then great. If we don't know what it is, then we'll go ahead and build it. And that would just be doing it like this, right? Let's get camera space P. Now the problem is get camera space P is actually not what we want anymore either, because we don't have a concept of a camera anymore. I mean, we do outside of this, but the sim region itself basically tracks where it thinks it is, right? It's got these two parameters baked into it, right? There's the region center and the region bounds, like that. All right. Excuse me. So we want that to actually be, we want the region, center, and bounds to actually be the things that are used, not any kind of a notion of a camera. So get camera space P really should never be happening anymore. Get camera space P is just a special case. So we want to kind of get rid of that and say, all right, instead of get camera space P, what we've got here is something else. We've basically got something that's like get region space P, if you will. So we have get region space P, and that just takes a sim region, right, like so, and it takes whatever that stored entity is, and that's, we'll do the conversion. So it does the diff, it does that subtraction. We're going to need the world pointer here, so I'm going to assume that the sim region will store a pointer to that world, so it can grab it. It will go ahead and use its P now, right? It's what do we call that? Its center, right? Or let's use the word origin, because that's kind of a little bit better. The origin of the sim region, and that should basically give us what we want to have happen. So there we go. We'll need to store, again, in the sim region, we'll need to store the world so that we can get back to it. So when we call begin sim, we're going to need to use that world parameter here, right? So we're going to have a sim region world, and we're going to have to set the sim region origin equals origin, sim region bounds equals bounds, like so on. There we go. Lovely. So that looks reasonable, right? And now we have a get region space P, which is exactly what we want. So we can pass the sim region to it, and it'll get us the region space P. And down here, that same thing can be used instead of camera space P. So now this can just use sim region origin. So sim region origin, and then min corner for the sim region bounds. Okay. And similarly in here, we should be able to do sim region origin, and this should be get region space P, and that should be able to paste take the sim region there, and this is sim space P, right? What did I actually get region space? It really shouldn't be called region space. It should really be called sim space, probably. Right? Sim space P sounds a little bit better. So let's say that get region space is going to be get sim space. Like that a little bit better. All right. So that seems good. Everything seems reasonable there. Lovely. And so what we're going to need now is, I guess we're going to need to sort of just do some sort of smushing here to smush everything back into a reasonable state. Here's the stuff that we know we needed before on here. So this will be a storage index, and this is basically something that tells us where this entity came from, right? This is all relative to the sim region, but we don't need to comment that really as much anymore because it's much clearer. We can put some comments at the top potentially to talk about that a little bit more. And so there we go. Now, our T-Bob is an animation thing that I don't think we want to have anymore, but what this does mean very clearly, and this was sort of something that probably should have happened originally anyway, which is that velocity is now something that has to be stored across frame boundaries, obviously. Velocity is something that has to be stored in the low entity as well, right? So in the low entity, in order for things to persist, we need to keep that velocity around. So that's going to go in there. High entity basically goes away entirely. That's just gone. So our sim entity has this information in it, that it wouldn't otherwise have needed. Same with the facing direction, and even, I guess, T-Bob for now can go out into the low entity. Because the low entity is really where we're going to be focusing all of our attention in terms of splitting things up anyway. So that seems pretty fine, pretty good to me. So we got our Z and DZ. This chunk Z, this stuff we're going to have to clean up a little bit because we did add vector 3s eventually, but we've never really quite gotten around to handling Z in a logical way. But we're going to postpone that for now, again, because one thing at a time. So that's all good. Now what we need to do is start actually making this work a little bit more straightforwardly by cleaning up the code that we do have and making it work within these confines. Now, one thing that I do need to do is I need to be able to actually allocate one of these sim regions, right? And so what I'm going to do is I'm going to, for the first time, introduce the concept of a transient, of the transient stack, basically. And so that's something that I think we probably won't have time to do today. So I'm just going to leave it as a placeholder, and then we'll do it tomorrow. So if I go ahead here and I say we've got our memory arenas, right? I'm going to say that we'll have some way of doing this a little bit more fancily in tomorrow, basically. So we're going to say here that we basically have a memory arena, which is the sim arena. And later on, we're going to have a more stronger notion of where that's coming from. But for now, we're just going to use that. And so from the sim arena, we are going to allocate the space that we need to store the simulation system. So what we need to do here is we just need to do a push struct, right, on the sim arena. Excuse me, to push our sim region, like so. We need to initialize that sim region. We need to initialize the entity bounds for that, right? So we need the entities, sim region, max entity count. We need the entity count itself, which we want to start at 0. And I'll go ahead and move these into the order they're actually in. So there's world, origin, bounds, max entity count. So the max entity count for now, we'll set it something high to do. Casey, need to be more specific about entity counts. In fact, this could actually be very high because this is a transient processing thing. We could really set this to extremely high because we're using a very large scratch space, basically. So we could think about that a little bit later, how exactly we want to deal with that process, basically. And then our entities, there was, I believe, was there already a push array? Yes, there was a push array. So what we can do is we can go ahead and get our array of entities as well. So there we go, sim arena. The count is going to be that max entity count, right? And then the thing, it is a sim entity, right? So that grabs all of those entities. And then when we're done here, what we'll basically do is, we'll assume that this arena releases the memory that we've used. So we basically grab all the memory up front, we do all the processing, and then we push it away, if that makes sense. And we'll have to deal with that later. So there we go. When we do our nsim, we just need to do the store back to low, which at the moment, I guess we can actually implement because we already have the code for it. It's a make entity low frequency, right? That's this code right here. And so if I just go ahead and add that in, we can just grab the parts of it that we wanted. Essentially, we already know what the we already know that we don't care about the high frequency index at all. All we care about is the low frequency index, right? And so that low frequency index is going to be whatever was in this storage index right here, right? So we basically have that entity storage index tells us where this entity is going to go. You'll have to excuse me, I'm still sick, as often I am on the stream. You can't stop programming just because you're sick. You gotta power through. I mean, if you're really sick, then don't program. If you're really, really sick. But I'm certainly well enough to program. Let's put it that way. All right, so I grab my entity here. Let's take a look at this here. We've got the region entity count. We're going through the entities. That's exactly what I want. We have the storage index. So the storage index is basically going to put these back into that low entity array, right? And so where we had that was actually in the game state, which is not necessarily where I would like them to be. I think those maybe would be better served, now that I think about it, in the world, but we can talk about that later. Let's see. To do. Maybe don't take a game state here. Low entities should be stored in the world. Something like that. But for now, we'll go ahead and do that. So in order to get the low entity out, right, we've got the low entity, which we're going to change the name of, I guess, to stored entity, right? So the stored one is going to be the game state, stored entities for now, something like this. We're going to go ahead and grab those out, like so. You know what, I guess before I change the name, I guess I could do stored entity is just still low entity, just to make the porting a little easier at first. And we'll just make that a to-do. To-do, Casey, change the name to stored entity. All right, so we grab the stored entity. We don't care about this, that was some debug code. We don't care about any of this. So I guess we didn't, in that code, we didn't actually do the packing there. In make entity low frequency, we didn't actually ever update that code. So this is just kind of garbage code, really. It doesn't even work anymore. So that's no good. Validate entity pairs goes away because entities are no longer paired in that sense. There's only a pointer back in one direction, so they don't really get validated. And force entity into high doesn't make any sense either. Offset and check frequency by area we got rid of because we now have that that concept. You never actually do move things out, so that's fine. So that goes away. So that's good. Make entity high frequency. We already essentially did. It's the camera space P part, which is done. So that goes away as well. This is the part that we actually, well, no, we don't need that either. Yeah, we don't need that either, really, because we've already replaced that entirely, as well as all of this. So yeah, so that's good. We don't really need any of this. All goes away. It's all toasted at this point. Add familiar. So what we need to do now is it's this part right here. Change entity location is really the part that we care about. So that was the thing that I was looking for this code to give me, and it turned out that code had nothing to do with it. So what I want to do here is, as we spin through them, this is the part that I actually need to update. We have a to-do here, which is basically like, you know, save state back to the stored entity. But right now, once high entities do state decompression. But for right now, I suppose we don't really have that. Now, maybe what we could do is we could say that all of the things exist in the sim entity as well. That's kind of an interesting idea. I'm not sure we want to take that step yet. So we'll just say that that's going to change a little bit later on. All right, so when we change entity location, we pass all the same stuff for the game state. And now this right here is that stored index. So this is the storage index of the entity, right? We have that low version of him. We know where he is because that's just that. And then we have his new position is basically going to be whatever we derive from that, excuse me, from that chunk space mapping. So what we'll do is we'll take that new same set of calls here, and now it's not going to be the camera's location anymore. Again, it's the region's location that we're mapping around, and then we have that offset from that stored in our entity, which is just the P. So that just works, right? Okay. So that all looks good. Pretty straightforward. Pretty straightforward. So that's good. And now set camera pretty much doesn't do anything, if I'm not mistaken. Let's take a look. So basically, we don't need to do any of this. We need this in some. We need to save just this concept of how big the camera was. So I'm basically going to. I'm going to move that into. I'm going to save just this piece, right? Like so. So we don't need this. We don't need any of that. We don't need this anymore. We don't need this. So really all we need to do here, this will be some kind of function basically where we, excuse me, this will just be some kind of function where we actually do our begin end sim. So it'd be something like, you know, sim camera region or something like this, right? And we wouldn't actually need a new camera P. We would just go ahead and say, all right, take the game state, figure out how big we want that camera bound to be, and then just go ahead here and do the begin sim end sim pair, right? So it's going to be like, oops. It's going to be like, all right, you know, here's our sim region. Go ahead and make it. We don't know exactly what that region is yet, but that's fine. We've got the world, and we've got the origin's going to be the camera. So this is the camera P, right? And then we've got those camera bounds that we just computed. So this is the region we want to sim. We go ahead and do that, and then we'll, you know, write some code in there for actually simulating the entities, which we haven't quite done yet. And there we go. So that's all we really need to do now. So sim camera region, we just collapse down. We could probably just move this whole thing back down into the main game loop. It's not really even a function anymore for all intents and purposes. So really what we got to do now is just that, right? We just do that right here. Nothing fancy about it. There's our sim. And then when we do this here, this is updating where the camera is actually supposed to be. So what we want to do there, I think, is I think we'll actually want to update the camera when we do the simulation end, right? So what we'd want to do is basically this. We'd want to do that right here. So this will update the camera for us, if that makes any sense. When we actually have things in the high set, right before we're done, if the camera was supposed to be following an entity, it will, and we might make this into a more general system later that actually can do stuff on anything, but that's definitely the right place for it, so we'll take a look at that when the time comes. All right, so that's about all of the restructuring that we need to do there. This will actually do that sim. Then we'll do the render, right? And I guess we don't want to end the sim till after we do the render, because we probably want to walk the sim for our rendering, right? So we probably want to do it like this. And in fact, the simulation and the render might kind of be working together, right? Because that's the way we were doing it before, and that may just happen. So we'll bridge the sim, we'll bridge across the two of those. And so then when it goes through these, we no longer have the concept of a zero index on high entity. We don't have to anymore, because now there is nothing that refers to high entities ever, for the most part. Excuse me. When I think about that, we are going to need a way for people to point. We are going to need a mapping, basically, that allows you to get from low entities that reference each other up to high entities. We could do that with a map, or we could do that in place. So we'll kind of have to see how we exactly want to do that. I'm not sure. A map is definitely one easy way to do it, or a hash table would be one easy way to do it. And I'm not sure if we want to do something. I think that'd probably be the smarter way to do it. Wouldn't be very expensive. I think that would be a smarter way to do it than actually threading it through like it was now, because I don't think you want all those pointers running around. So I think we'll probably deal with a hash table. So we're going to get rid of the concept that that you ever index intentionally into the high entity array. That way you'll just use a pointer or something similar. All right. So I think we are good to go there. So here we'll just go through that sim region, its entity count, like so, entity index, like so. This will get much cleaner now, I think. And this will have an entity like this, sim region entities. And so that sim region, we'll go ahead and loop over that. We don't need low entities anymore, although we kind of still do have to do them temporarily, because we aren't really fully decompressing in and compressing in and out or anything like that. So we're going to temporarily leave those in until we get a little bit further along, excuse me, on the porting. So we'll still have our entity and our low entity will have to sort of pick up the slack in a couple places. We don't care about this anymore. We get our DT for the frame. We have our low entity's facing direction still there, low entity, like so. Let's see what else we have to do. This is all drawing. These are all just drawing calls. So update sword. For now, I guess we'll take both of these. And same with update familiar, update monstar. those will want to actually pass both of them probably. And then from there, I guess the high entity, let's see here, what have we got? I don't know, again, since we're kind of in the middle here, I don't remember where the split was on some of these things. So let's see, Handmade, sim region. All right. So yeah, so most of this stuff is actually on the other type of entity now, but that's okay. We're no longer doing this piece group. This all looks completely non-entity based, so that's good. So really the only thing we're dealing with is this. This is still using that entity P like so. High entity Z, that is still, yes, entity Z, entity Z, entity Z. These are still entity. Everything here is still on entity. And that's fine. And it looks like there isn't anything else in particular. So those still are on the low entity, which is all good. So that's all good for the most part. All right, that looks nice. So really what we have to deal with now is just the update calls, I think, is most of it. And the other thing we're going to want to do is move that code from the player. We're going to want to move that down as well. All right, so let's see how we're doing here. We got to go ahead and include our sim region as well. So handmade sim region.cpp and handmade sim region.h. I don't actually think that should go there. That should probably go up here, like so. Let's go ahead and start our debugging process. Let's get rid of this for now because I want that to be gone eventually entirely. So let's just assume that we get rid of it entirely. Let's see, sim region entities. Excuse me. Let's go ahead and do that Casey style. There we go. Binary equals, no operator found. Let's see, simp, right, that's a pointer too. Let's see, again, sim state for the low entity, that's actually source entity, just a typo. Game state low entities plus low entity index, the game state is undefined. That is actually true. It is undefined, so we have to pass that here as well. And so this would be another comment where I'd say we pass the game state, but to do if entities were stored in the world, we wouldn't need the game state here, right? So that's just something to think about, right? All right. So let's see. This is actually the sim region bounds. Let's go ahead and compile that. We've got our entity is a sim entity. That's proper there. We have our, oh, and we're at the Q&A. So I think I'm going to stop soon. I might just quickly go through the rest of this pass just to clean up some of these, but that's where we'll end it. Stored entities. What are the stored entities? That is still low entities for now, right? Am I right about that? Low entity to low entity. Star. There we go. Entity. Camera following entity. Force entity into high. Okay, so we don't actually need that anymore. That would basically just be something that we use to sort of get which that is. And so that would maybe be our first case to do that hash table. So this would basically be entity mapping hash table. And that's something that we'll want to do. I guess I'll put that here as well to do. Need a hash table here to map low entity indices, or I should say stored entity indices, to sim entities. We'll do that. All right, so it's time for the Q&A, so I'm going to stop here. I think we have plenty more work to do to sort of get everything organized, so I don't want to go any further into the Q&A. We'll do it tomorrow properly. So yeah, if you want to go ahead and preface your questions with Q:, that would be excellent so I can see them. And please try to keep the question stuff we've done today or on previous streams. If you want to ask questions about other stuff, please come 15 minutes before a scheduled start time of a stream. And we do off-topic questions then. Recommendation for names. Instead of stored entities, you can have the stasis entity and stasis region. For the high frequency, you would keep the sim region, sim entities. Yeah, I don't really like stasis necessarily because they're not in stasis. They're just being stored temporarily. They're still active entities in some sense, right? So I don't know. I'm not sure. It's hard to say. Sim region and sim entity seems good. Storage entities, I don't know. World storage and stored entity, I don't know. We'll have to think about them. They're kind of just being stored away till we need to come grab them out again. Since we know that an entity's speed is bounded, couldn't we calculate a sim region with bounds such that no entity can move outside of it during the frame? That way anything that the entity could collide with will be pulled into the sim region. No, unfortunately not. Because it's an unbounded problem, right? This is what I was trying to say. So let's say that you start with this sim region bound, and you say, all right, these are the entities that are in that bound. Well, I know that this person can't move any further than this, right? So my new sim region bound would be here. But the problem is that now pulls in this entity, and so then you have to do the same process again. Oh, well, I know that this entity can only go that far, so here's my new sim region bound, which pulls in this entity. And I know that that entity could only move that far, which pulls in this one, right? So what ends up happening is if all the entities in the sim region are considered live, it will grow forever to encompass the whole world. So what you have to do is have a notion of a lot of live and non-live entities inside the sim region, and it'll be really easy for us to deal with. We don't have to do any special code. All we have to do is not update ones that are outside that boundary, right? In fact, I'll make a note of that here just so we remember to do it. Basically, what we want to do here is to do check a second rectangle to set the entity to be movable or not, right? And maybe that should actually be done in here. Well, we'll see. Because entities could get created. Yeah, it's a long story. Anyway. MyPaint source code. Ah, cool. So MyPaint does have source code, so I could possibly go fix that. How many to-dos do you have? A lot. I put lots of to-dos in the code. Basically, I don't hardly ever look at to-dos until later in the project. But I like to put them in because you can always go look and go, oh, that's not relevant anymore, and delete it. But if you forget one, that's bad. So at the end of the project, you want to be able to have a way to search for them and just see and make sure that there wasn't something critical, like to do, this will explode. You don't want that, to stay in there, right? So we have a thing, actually, in here somewhere. Let's see. So we have a thing called static check, right? And static check will check for global variables. So we can do, in the code base, we can say static check. Oops. And that'll tell us everywhere that anyone used a static, right? Which is pretty awesome, because we can verify that we never have them, which is what I wanted. And so that's just kind of cool. So what we can also do is we can make a similar thing inside our static check, which is like to-do check, right? And that would be something that would allow us to do just a quick sort of validation thing where we do like to-dos found, and then it would just look for that, right? Or something like this. And so, see? And this way I can just quickly, like at the end when we're shipping, we'll go through and remove all the to-dos that are no longer relevant, and we can go through and address the ones that are relevant, right? So to-dos are very good. I think they're a good thing. They don't cost you anything to put in, and if they're unlike comments that are trying to like tell the person something, I don't like to use comments a lot because they tend to end up being wrong. To-dos really aren't that way because you can quickly, when you're doing your to-do processing, you just go through and see if they're wrong, you just throw them out. They don't have that same negative downside that comments do to me. How will you handle the disparity in update rate between off-screen and on-screen entities? Does it matter? The answer is hopefully it won't matter too much, but it might. And so really what we're going to want to do is we're going to try and want to keep that disparity low. Like hopefully we'll be able to write some pretty fast update code so that we can handle lots of entities and it's not too big of a deal. So that it will be like a difference of like normally entities update at 60 frames a second and then off screen, you know, the rest of the world updates at like, you know, something like instead of 30 frames a second or 60 frames a second, they operate at like 5 frames a second, which isn't that big of a deal. Like things probably won't break. But if it turns out that it's more like once every 5 seconds or once every 10 seconds, we're going to have to do some extra work to support that. But we'll see what happens when we get there. Will the seam region away from the player cause large time steps from the norm? Yeah, so that's basically the same question. So the problem is always going to be, we still want to simulate the world as fast as possible. So we're still going to want to try and keep the number of sweeps through the world to be relatively high. But yeah, hopefully it won't be too bad. If it is, then we have to take steps then we have to actually start writing some extra code to do more efficient updates of people when they're in that other sim region, right? I missed whether this new system is based around discrete rooms or integer map coordinates. If it's based on rooms, would it be trivial to think in chords instead? It's not based on rooms. It's free floating. It's just a camera region, and that camera region can be anywhere. What will happen if your sim region and player location are at the same place? Will it bug out? No, so we have two options, and I don't know which one of them we're going to want to do. But basically what we'll have is we'll probably use something like a generation index, and the generation index will tell us how many sim steps forward each thing has gone. And so what we'll probably do is store some kind of a generation index, like, you know, I'll put a note in here too. So do it. Generation index, so we know how up to date this entity is. Basically, we'll store something in there that lets us know how recently he was processed. So if two regions overlap, or if the camera region comes into somebody who hasn't been updated, it needs to know how much updating to do for them. We should basically be able to do something that does some reasonable job there. Again, it's going to still be a little complicated. We'll have to work out a couple things because, again, scaling up everything and making everything work nice and clean is hard. Though I think architecture gets us a huge portion of the way there, which is good. But there are still going to be a few things that we're going to have to see how they work out in practice. Why is the low-high frequency system so important? Isn't creating basic gameplay rules and AI interactions in a small world more aligned with your philosophy of doing the simple thing first? No. So I think I don't want to give a misleading... I want to be 100% clear. When I say do the simple thing first, that doesn't mean do the wrong thing first. What I mean is implement do whatever you can to get the thing working that you need working. Right? And I know I want to be able to scale the entity count up high. That's a requirement. It's not an option. I'm saying flat out, we want to be able to create as many entities as we want. Like if we want literally to have 30 million entities in this game, I want it to be able to work, right? So that's a hard requirement it's not negotiable. So I did do exactly what I said, which was write what would make that work. I just started typing it, and you saw what we did. We did the low frequency, high frequency. I was like, all right, let's try this. Let's try mapping between them, and we kind of got that going. And the same was true of the large world thing. I was like, okay, we got to map in and out. And so I did exactly that process of going through and doing whatever came to mind to get it working. And then I realized right now, which was very happy for me, I realized last night, because I felt like eventually we would see the right solution. I think we now have. I finally was like, yes, now I see how to architect this so all of the problems go away, right? And I think that's what this will do for us. It'll basically get us to a point where now everything's nice and clean, and it's very easy to code for. And the reason that I wanted to do this first was because everything we write from now on will be in terms of this thing. So starting with something that doesn't handle any of the things that we need to handle is not the same as writing the simple thing first, because writing the simple thing first is only valuable. Simple isn't the right word for it, I guess is what I would say. It's whatever you can think to do that satisfies the requirements. And sometimes that means the simple thing, right? And in some case, I would even still describe it that way. Write the simplest thing you can think of that does what you need it to do, which is what I did. But it still needs to do what you need it to do. You can't write something that doesn't do what you want to do just because it's simple, because then you've learned nothing, right? And so that's really, really crucial to understand the difference between those two things. Over-designing means trying to actually make a complete system before you actually understand how it has to work, right? Moving away from that doesn't mean writing something that doesn't actually satisfy the requirements you have. So what you want to do is you want to write something as straightforwardly as you can that satisfies the requirements, and then you want to architect up from that. And that's exactly what we did. I wrote the most straightforward code as I was going, and you saw how it was kind of getting complicated and nasty. And then I was like, I see how we can do the architecture now that makes these things become clean. So the other thing to think about is these systems are different. So when you said, why not get AI interactions or gameplay rules, those are different systems. How we handle where things are spatially has nothing to do with how the AI works, right? The AI has to use those systems, but it has nothing, it still has to be a completely other design problem that we're going to work on, right? And so as I went, you notice that I kept adding new things to the system. Like I added that floating familiar. That was a step towards adding AI and game rules. We started adding the sword. That's exactly what I was doing. But I'm constantly looking at all of the pieces that are in play there and going, oh, okay, I see. We've already gotten to the point, even with just these things in there, where it's becoming difficult to work on the code because of the complexity that's involved with maintaining the high and low frequency and the positional stuff. And I know I need those things, so it's kind of like now is a good point, if you could think of a way to do it, to level those things up to a better architecture, right? And I was reluctant to do that for a while because I hadn't thought of anything that was a clear win. But now, after we got enough out there, I was like, I see what the clear win is now, let's do it. And so I think this is the right thing, and that's why I did it now. Instead of doing it before, again, I didn't think about it clearly enough before, so if I'd done something like this before, it would have been a bad idea. And it's hard to say when you get those ideas in your head what they should be or shouldn't be. That's kind of a little bit of experience talking. Knowing when you get an idea that you're like, this one really does solve a bunch of problems that I've been having. I've seen all the problems. I think, this is a good one to go with now, versus going, I don't think I quite have enough information yet, right? And so making those judgment calls is obviously something that it takes a lot of practice to know about. How will we update low frequency regions given the sparse nature of the world? Probably we'll just spin through tile chunks, would be my guess. We'll just go through the hash table. Maybe we'll go through the hash table and pick out tile chunks, look for tile chunks that haven't been updated in a while, update around them, which will pull in any tile chunks that are nearby. They'll do the update, mark all those tile chunks as updated, and keep going. Is there a major advantage to using fors instead of whiles? No, for loops and while loops are exactly the same in terms of code that gets generated. They're just notational. So basically, like if you want to, anytime you see a for loop, you could just write it as a while loop, right? So like that's the while loop version of this for loop. And so there's really no difference in them. It's just the reason that people prefer for loops oftentimes, and the reason that I myself write for loops when I write them, it's because it shows more clearly when you're reading what the elements of the loop are. it kind of bundles them more nicely together. In a while loop, they're kind of spread out, especially when there's a bunch of stuff here, right? You start to lose track of what the loop parts are, or if things get inserted in here, right? So the for loop is just a nice way to kind of bundle those things together. What will the entities that are not visible on the screen be doing? I can't really think of examples of things that need to be updated if they're far from the player. So an example would be, and again, until we actually get to the game, our specific game will have specific needs. But giving an example from, like, if you imagine just a random game, the sorts of stuff that I think would be nice to be able to do anytime we want is, let's say that the player, goes ahead and excuse me, goes ahead and talks to an NPC, and the NPC says, "Oh, okay, I'll go fetch that thing." I would like the NPC to then be able to go and walk somewhere else in the world, no matter what you're doing, fetch the thing and bring it back, and then he's there again, right? And maybe he goes there and he looks for it, but it's not there, so he then goes and looks somewhere else for it. And if you were walking around and went up somewhere, you might see him walk by, you're on a screen and the NPC comes on the bottom and walks by and walks off the top. And you'd be like, "Hey, I know that guy. Where's he going?" And you could follow him. I just want to enable stuff like that. I know games don't do it very often, but I think they'd be cooler if they did. It's just kind of a nice emergent behavior thing. And so since it's an interesting programming challenge, I decided to include it in our engine because I think it's worth us figuring these things out. It's part of the teaching process of showing how to work through programming problems that are difficult. If we just wanted to make a game where we just had a simple, if we were just going to clone Binding of Isaac or something, it's really easy to program, right? There's one room, nothing happens anywhere in the game, the worlds are tiny, there's 5 enemies on the screen, right? We could trivially write that. We've already written most of the code that you would need, right? So the idea is not to show how to program the simplest game possible, because I don't think that's very interesting. The idea is to show how to program a game whose game design is vastly more complicated than 90% or even 99% of the games that you might see. So you can actually see how to work through very difficult architecture problems, not just, hey, I've got a simple platformer or something, because that's just not that interesting, I don't think. How many low entities does it take to screw in a light bulb? Well, now if you actually are talking about just stored entities that are not mapped into the simulation set, there is no number of them that could screw in a light bulb because they don't get a time step. It's only once they are simmed. So if you're talking about, if you include the fact that there's the low frequency simulation thing going around, simulating them, then, I suppose it depends on the update entity call for that particular type of entity and how many, hit points the light bulb has, that sort of stuff. Your voice is about to throw in the towel. Be careful, we need you here tomorrow. It's true, my voice is. Tomorrow's stream may be a silent stream where you just watch me rearrange the last remaining pieces of code and compile this. For your sparse storage, why not store the XYZ coords bit shifted into an aligned integer to use it as a composite key into a dictionary or hash map? So we're basically already doing that. The only thing we don't do, I'll just go ahead and load it up. So here you go. Where's my get chunk? It's in here somewhere. There it is, get world chunk. So if you notice, that's exactly what we do, right? There's the hash slot, there's the positions. So what you're saying is exactly what we do. If you're asking literally why we don't bit shift, it's because, well, there's to do better hash function, so we haven't analyzed it. But oftentimes, just packing the bits together isn't the best way to throw things into a hash table. So we're actually multiplying by primes. Not that that's particularly better. We actually want to analyze these and have some real primes here. This is garbage. But bit shifting is probably not what we'll want to do. because we want to do something probably that tries to look at how our world gen tends to generate worlds and make something that is going to use the hash table well for those kinds of layouts. Do you approach design in a similar way to your architecture, i.e. exploration-based design, the design sort of merges itself organically, etc.? So if you're talking about game design, I'm not a game designer. So I can't really comment on that. I don't do game design. I just do game programming. Is multi-threading in the scope of topics for the project? It sort of wasn't. I mean, it was for the renderer, the software renderer, because that was a good place I could do it that would make sense. But it wasn't originally because the Raspberry Pi only had one core, and I wanted to port to that eventually, probably. And so, since that's also our slowest platform, being multi-threaded didn't seem like much of a good idea. But all that changed in a big way because recently they announced that the Raspberry Pi is getting a refresh, and it's going to have an ARM Cortex core, an ARM Cortex chip with 4 cores. So now multi-threading is absolutely on the table, and updating multiple sim regions in parallel is absolutely something that we will probably want to do when the time comes. If a faraway room gets updated and the rooms around it are updated too, don't we have this recursive problem where the around rooms need their neighbor too? No, again, because you can do simulations half-sided, right? We can do like just move the entities here in this region, do those moves, right? And the things nearby them aren't allowed to move. We can do stuff like that, right? And we do introduce problems like if this were some kind of a multiplayer online game that we're working this way, it would probably be a bad idea because you really care about things like fairness there and all these other sorts of things. But we have the ability to sort of tweak, you know, all the things that are getting updated out there are completely under our control. And we have the ability to tweak their AIs and change the way their AIs work to make it so that that's not really going to cause a lot of huge problems. If we see it causing problems, we can probably fix them. So I don't think we're going to have a problem with that aspect of it. But we'll see. You know, we never really know. How much work would it take to turn the game you're making from a 2D world into a 3D world? I'm not really sure how to answer that question because it's very ambiguous. Are you talking about rewriting the Crytek engine, or are you talking about literally you just want the things to be, you know, 3D models you loaded out of Maya, but it's the exact same game otherwise, right? Because there's a huge difference between those two things. To clarify my early design question, I just mean as far as your design decisions for Handmade Hero. Well, so far, I haven't really done exploratory design with Handmade Hero because I mostly did it just sort of on paper because I haven't obviously been doing any of the design on stream. So I can't really do emergent design in that sense. When we actually do implement all the game stuff that I sort of already wrote down that I thought we should do, once we get all that working, then yeah, we probably will do fairly organic design in that way. Because like I said, I'm not a game designer, so I don't have really strong opinions about that necessarily. So we probably will do stuff as like while I'm on stream and I'm like, oh, we implement this feature, and oh, it would be cool if you did this, we'll just do that. And so there probably will be a fair bit of design that's very emergent there because, you know, again, the focus of this project is on programming, not design. And so as we think of fun things to implement, we should just implement them and see how to program them. That'd be my preference. All right, I think we're almost out of time. We are almost out of time. It ends at 10. And it looks like we don't have any more questions. So we're right on time. We are right on time, people. So that's pretty good. That's pretty good, I would say. In my humble, no, that's not really that humble opinion. All right. Well, I guess since we're at the end of questions, now is a good time to wrap up the stream. That's very good. We're right on time. And I'm pretty excited about where we're at. I think this is going to help us out a lot. I liked this design decision. It's looking pretty good so far. Oh, you know what I should do? I should save this out so it'll get shipped out now. It's the blackboard.art file in the MISC directory, so that when I upload things, in case anyone wants to look at the diagrams. But I think that is it for today. So thank you everyone for joining me. It's been a pleasure programming with you, and I was very happy to put that stuff in today. I think tomorrow is going to be great when we wrap it up, and we can kind of start focusing on the low high entity thing, because now that I actually feel really good about that sim region stuff, it gives me those really well-defined places to do the map in and out, and I've kind of been waiting for the right time to start thinking about that map in and out, and so now that will sort of materialize, I think, over the next week. So what I probably want to do is over the next week or so next week, probably all next week, throw a ton of stuff into that low entity, like whatever we can, finish the hit point stuff, add, I don't know what else in there, but just whatever we can think of, pickups, like maybe you can go walk around and get different swords to throw, and I don't even know, chests you can open, that kind of stuff. Just pile a bunch of stuff in there so that we really bloat out that low entity class huge. Right? And then take a look at that and go, okay, how can we now start to think about how we want to deal with these, where we know we're going to have tons and tons of these guys, tons and tons of these things. How do we start managing that? And sort of in the same vein, I'd like to get the property transference stuff in there. I talked about that. Something where, you know, things touch other things and they pick up properties from them, or, you know, you cast a spell on one thing and that thing keeps that state. And so that when it does something later, it imbues that state to something else. I want to kind of cram those things in there so I can start to see how they feel. Because that's the next thing that I want to nail down, entity system wise. And I think that's going to be really important. So I want to push towards that. I don't know if we'll make it before break. People have been asking for a week off for quite some time. And so that first week of March, I said we could take off, because I'm going to be away anyway. I'm going to be visiting my parents. So it's easy for me to just go, okay, we won't stream while I'm away. So people will have that week to catch up. So we've got 2 weeks. I don't know if we'll get all the way there. Hopefully next week, and then the week after, if you just keep piling stuff in there, I'm hoping that we'll be able to kind of get to a point where I'm comfortable saying there's enough things in here that we can start to make decisions. Don't know if we will or not, but I'd like to do that. If we get there before a break, that would be pretty cool, because then we'll have that whole break to think about it. And when we come back, we can do the entity system. And that would be pretty cool. So we'll see. That's where we're at. Again, thank you so much for joining me. I will be back here tomorrow night, 8 p.m. Pacific Standard Time. I guess, tonight was a late start because we wanted to watch John. Obviously, anytime John is streaming updates to his programming language, I want to watch that. So we always delay the stream when that's on. But tomorrow night, there's no other things going on as far as I know. So 8 p.m. Pacific Standard Time tomorrow. Right back here on Twitch. If you would like to follow along with the source code at home, you can do so right here. Basically, if you pre-order the game, you can download the source code. We post it every night after I'm done programming. And of course, you can go check out the video archive. There's videos all the way back to day one, which tell you exactly how to set up a build machine, how to work with the source code. It shows you every step of the way how I built it. So you can go through every last thing and see how it was made. So that's pretty cool, and you can do that here on handmadehero.org. We also have a Patreon. If you want to support the video series, you can always subscribe to that. And there's a news and forum site you can check out, which has a bunch of stuff like the schedule for the week. The schedule for the week is also tweeted by the tweet bot. If you want to have them delivered right to your Twitter account, you can do that here on the tweets button. But the news and forum site has that. It's got a discussion board. It's got old episodes annotated. You can go on the episode guide. It's got ports to Mac and Linux. Got all kinds of good stuff. So check that out. If you're trying to learn from the stream, it's a great place to go. So I think that's about it for today. Thanks everyone for joining me, and I will see you back here tomorrow.